buildingSMART room session as part of the International Standards Summit, Rome 2023. Thank you for joining. My name is Sheila Kurailam, and I will be your moderator today. Today's session is titled IFC 4.3 is here. This session is scheduled to last 90 minutes with time for questions at the end, hopefully. The session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to our speakers, I would like to remind you that this is a hybrid event. For the online attendees, your microphones will remain muted for the duration of this session. If you wish to ask questions, please use the chat box in the control panel. For those in the room, please try to keep the background noise to a minimum and raise your hand if you wish to make a comment or ask a question. I would also like to bring to your attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted, and the process for their adoption is transparent, and standards that are developed do not favour any particular provider and are open, non-binding and accessible to all. Please take note of our antitrust code of conduct, which is up on the screen now. And with that, I will hand over to Winfried.
Thank you very much, Sheila. Welcome to this session of the Railway Room. As you see, the title is fitted to the place here. We have IFC 4.3 we have worked on for infrastructure and especially rail the last 5 years on IFC 4.3. This standard is now in the ISO process and hopefully soon available as an official standard. And this session should show what our stakeholders and friends and partners want to use from this standard and how they want to go further in future in the IFC and building information modeling part. So I don't know, is there the second slide? Let's see. Yes, it is there. Before we start, I want to make a short advertising for the InfraBIM Open in Lyon, which is from January 29th to the 31st, 2024. So if you have time, go there. A lot of infrastructure topics would be discussed there. And now let me hand over to my colleagues here. Adrian Wildenauer from SBB, Edouard Chabanier, and Ashraf from SNCF. Dashuang from CRBIM, and my colleagues from UIC, Pierre, Tane, and Airy. So, Adrian, I think you will start over, so let's go to the next slide deck, please.
Let's look if this works. Excellent. Before I start thank you, Sheila. Before I start the presentation, I would like to draw your attention to this picture. That's my colleague. He's 35 years of age, working now 5 years for the development of IFC. And you see he's grown a lot of experience after that. So, but let me start. I'm Adrian Wildenauer. I'm the head of BIM standards at the Swiss Federal Railways, and we are happy to be part in the IFC project. But let's proceed, or let's start. The Swiss federal government, we have has given us a very easy task. So railways should become, or shall become, more interconnected, more performant, more efficient, more cost-effective, and more customer-friendly. So that's a very easy task to achieve, I think. So at least from the view of the government. But with this task we received, it can only be done by valid data, not depending on the use. So what does it mean if we shall become more interconnected, performant, etc.? So it means that we have requirements to data. And the requirements to data in terms of interconnection are that as we all experience, the habits of our customers are changing. So we need reliable data to track and offer new database services. What is more, we need to be more performant, and we need the integration of GIS and BIM data. So there's not only BIM, but there's also a real world outside. We need to be efficient. We need to be data that's available when needed and in the required granularity and quality to enable additional services based out of these data on our tracks. We need to be cost effective as well, and we must be economical with our resources. And to be honest, we are just trustees as the Swiss Federal Railways. We are trustees to the taxpayers. We have to be efficient in every franc we spend. Can I make a bank joke? No, I'll just leave it. Sorry.
Not as a Swiss.
Not as a Swiss, sorry. At least we must be cost effective in our spendings, and we must really be economical. So we must spend our money wisely. And of course, the customer is in our focus, or is the focus of our activities. We must be able to always support the customer in every decision he's making in terms of his travel. So we need to offer additional services. So this means a tremendous amount of need for data. It's to be honest, it's information containers galore if we talk about information. But let us break it down why we are investing so heavily in building information modeling. I'm not sure if you can read out the figures. I think they're quite impressive. 3,500 buildings, 3,000 kilometers of tracks, operated lines. We have around 5,000 bridges. I've learned today that we have 12 bridges more than the Swedes. So they're not here. But I think it's an impressive number, and it's a system, it's an ecosystem of assets we have to maintain. But still, in every of these 2,000 projects you see on the top, we have to operate it with external partners. We have to operate it. We have to plan, construct, and operate it with various partners. And we, as I mentioned before in the morning session, we are not plan and build for the planning and building phase. We are plan and build for the operational phase to have an stable operation later on. So that's what we call the life cycle based data management. So as I told you, we have 2,000 construction projects a year. That's a higher number because of COVID. It's like a wave which has to be done. So, and if we calculate or just estimate very roughly, we have an average of 10 directly contracted companies involved, an average of 10 people per company, an average of 10 interactions per week per person per company to SBB. And that's very optimistically an average of 1 delivery result per 10 interactions. I'm optimistic. So this results in 2 million interactions per week, just information containers traveling around in our company. That's 104 million interactions per year. And that's around 10.4 deliveries, 10.4 million delivery results per year in forms of calculation, PowerPoint, the most important file for BIM Excel, logs, mails, documentation, whatever. So, and the unfortunate thing is it has an exponential growth in terms of information. We need to be able to cope with this kind of information. So the question for us is, how do we deal with this not too bad number of information we are getting every year in terms of files, logs, results, calculations, etc. I just wanted to raise the question I did before. Is a standalone use case a solution, which is heavily driven in the industry? Is that a solution? Or what can we do to reach our goal for the lifecycle data management, lifecycle-based data management? What we are doing, we strive for the interconnected, interdependent use cases linking business and IT using IFC 4.3. So we are combining the business aspect, operating of trains, operating of railway lines, and the IT necessary for maintaining it. More importantly, we have a strategy 2030 of SBB, and we don't do a revolution in the data management, we evolute our data management approach. So we're not doing everything new, we start with the existing data management and evolve it to cope with this, how much was it, 10.4 million information container. So, to sum it up, I already said it in the morning, what we will do is, as a result of the 5 years work within the steering committee and within IFC 4.3, we will start tendering the first around 100 projects, new projects, based on IFC 4.3 in July 2024. That's not too far away, so the industry must be ready, and I've heard on Monday, was it Monday? Monday, that every software vendor said they are ready. That was noticed and already distributed to the board of SBB, so that, sorry, and no, just kidding. We need the industry to be ready to cope with this amount of data, with this files, with this format, with the IFC 4.3. And what is more, as I told you, we have around 2,000 projects of every size, less than 1,000 francs to billions of francs. And we will not only double, but we will increase the number of projects every year to make it a more smooth approach to reach the market participants. We consider IFC 4.3 as the start of the digital continuity of the industry, and it's most important that we don't see IFC at the end of a development of BIM standards. It's just the start of these interconnected, interwoven standards we consider. And I brought this slide, I think, last year already in, I can't remember where it was not Montreal, the summit before, can't remember. Most important is the industry should collaborate on the rules, but compete on the game. That's a really important thing to understand. It's not, we don't need 15 standards from 15 different companies. We just need one standard, which is IFC for us. And we and the companies should focus on aiming better, doing better, competing better. And that's one of the most important parts, in my personal opinion, what we should do to reach the goal, our goal of having around 100 projects executed in 2025. So to sum it up, to make a gist, it really looks like this in Switzerland. So you are happy to join us here in Switzerland. But to sum it up, data requires structure, a structure like IFC. A structure requires discipline. Every company needs to follow the rules of, or the structure of IFC. Nevertheless, this discipline requires order. There must be an order while filling in all this stuff. Order requires standards. Standards require consent. Consent requires participation. That's why you're here. And participation requires knowledge sharing. We are sharing at SBB, we are sharing everything we have, every document, every data catalog, every, well, you name it, to be able for the market participants to gain new knowledge and to participate in all the projects we are tendering. Knowledge sharing requires data. So it's kind of a circle. And we need data to reach our goals, and we need standards. So, thank you very much.
Thank you, Adrian. may I hand over to Edouard or to Ashraf? I don't know who will start. Thank you.
Yes, I will continue. Thank you, Winfried. Thank you, Adrian. This one? No, it's mine.
Because the camera shows that's funny.
Sorry. Okay. So, good afternoon, everybody, or good evening for our guest in online. I'm Edouard Chabanier. I'm from SNCF Réseau. I'm Deputy Head of Standardization and Regulation Unit. And I'm currently leading the standardization domain of SNCF Réseau BIM deployment program. And I'm strongly involved in the IFC 4.3 implementation. So, like Adrian, we show you some initiative for our company. Okay, SNCF Réseau is the infrastructure manager in France. But before we start, some numbers. Oh no, it's okay. So, just 3 numbers because it's a little bit late. So, SNCF Réseau, it's 28,000 kilometers of lines. We have more than 1,600 rail project, major rail project. It's like renewal or upgrade, and a few hundred of these are BIM projects. And now we have more than 1,700 people, employees, that are training to BIM solution or BIM tools. Before we present our initiative, I will show just a slide that I showed in 6 months ago in Montreal. It's our strategy, our open BIM strategy, because for SNCF Réseau, the open BIM it's a core value already implemented in our strategy. So we are really convinced of the importance of open BIM for an efficient and sustainable implementation of BIM solution and the digital twin. We can see here the interoperability with IFC 4.3 and ISO standard for September normally. And also for us it's very important the independence from software vendors. So we would like to have a multi-source data platform and also an agnostic common data environment. This presentation, it's in 2 sequences. Yes. So we have now a project approach to respond to this strategy. It's a big project called Minerve. So I will make a presentation of this project. And after, Ashraf will present you some concrete example of IFC 4.3 implementation in Minerve project. So, yes, this is the logo. Before detail the Minerve project, let's start with the context. So, like Adrian said, today we have an ecological and digital transition of the sector. And among the needs expressed by the French railway sectors, we can mention the need for a digital continuity, the need to align the industry with the railway BIM tools and methods, and also we have to share with all the stakeholders the methods and the tools. And we need to develop BIM in a construction phase, why to saving resource and to have some models, sample models. And also we can see that today the digital twins is not really developed in the operation and maintenance phases. So we need to develop more the digital twin. There are some researches, but we now try to develop the digital twin. So we're convinced of the necessity to accelerate the digitalization in construction and maintenance operation phases with a double ambition, develop the technological solution, and also boost the entire railway construction ecosystem. So the conclusion is to build the beam and the digital railway twin with all the industry sector, like Adrian said also. But, yes. Which are the objectives of the MINER project? I don't read all of this. There are some keywords: design and construction methods and tools, anticipate and optimize, developing the digital twin, I already talked about, improve resilience, industrialize, standardization, and shared vision. Shared is very important. Build a collaborative ecosystem. As we can see, there are more than half of these green keywords that could be related to the interoperability and the standardization. So with the IFC, so we'll see just after how we link with the IFC. So to summarize, the main objective is to contribute to a transition toward a more efficient, more reliable, and more environmental friendly railways construction and operation. Before develop the organization for my project and the partners, I would like to develop a little bit the aim of the object. Why this objective that I just presented? Because today we have two things. One of the things is the technological lock. And the second thing we need for this technological lock of some innovative responses, as we like to build and guarantee digital continuity over the entire life cycle of an infrastructure, railway infrastructure. First of all, it's for the railway beam. We talked about continuity, but today we have some continuity, digital continuity, but not really. In France, we use many software solution, and in some teams we're still using like Excel spreadsheet. It's a continuity that we would like to achieve, but today we don't have it. And also we have a problem with the existing conditions to acquire the existing condition for some project. For example, we have equipment infrastructure that are several decades old. So for some of them, we don't have plans anymore. Or the cost of digitalizing the existing infrastructure is prohibited, so it's not possible. So we can do something to respond to this technological lock by mass production of existing big models and using artificial intelligence. And the second is about the digital twin. Today we have some small digital twin, but they are heterogeneous, they are not linked, they are not complete, and the data not flow very well, it's not integrated. So we need a reference architecture for the digital twin. We set up a consortium with some partners. We have 6 actors like founded partners. And donc it's SNCF, the group SNCF is SNCF Réseau, SNCF Railway Station and Connection, and REP, which is an architecture studies and multidisciplinary consultancy. And we are the project leader. And we also have some railway sector partners like Quo Vadis Rail, a rail infrastructure company, RWR3, which is a Paris area transportation administration. And we have some partners from the academic side, like Central Supélec, which is a top French engineering, graduate engineering school. And IREX. IREX is the French Research Institute for the Civil Engineer. And also we have many partners of the entire sector, railway sector. And someone are in this room, like CISA or Regis. What is important here is the budget. We have almost 35 million budget for this project. And half of this budget, it's a financing for the Ministry of Transportation. It's a very big project. About the project organization, the task, I don't detail all the task. The task of the project are organized around two key elements. So we have in a green the industrial research, and in blue the experimental development. And we can find some tasks that respond to the objective mentioned before. For example, we found the digital twin development for the operation and the maintenance phases. This organization, with this organization, all the actors find an interest in developing their market. For example, for us is the national railway network. For Quo Vadis Rail, it's all project of infrastructure works. For RWR3 is the offshore, of course, the metropolitan transportation service, but also some project, transportation infrastructure project outside France. And for the education research and IREX side, there are also some interest in the subway, urban development, and collaboration with all around Paris, Grand Paris region. It's called Ile-de-France. To finish this presentation, general presentation about Minerve, just a few words about the economic opportunity and expect the outcomes. For the railway sector, CAS, RTP, Quo Vadis Rail, our expected outcomes, it's first of all the reduction of the environmental footprint, cost-effective for the project, resource saving, and also the two keywords in green: interoperability and standardized method. So we talk about IFC. I will let the floor to my colleague Ashraf, who will present some concrete examples concerning IFC for the tree implementation.
Okay. Thank you, Edouard, for the invitation. So, good afternoon, everyone. My name is Ashraf Tsul. I'm an electromagnetic compatibility engineer. I was involved in IFC rail project as a telecommunication domain expert in phase 1 and as a test leader in phase 2, and I continue to participate in phase 3. And I was part of railway telecommunications teams that has developed all the BIM solutions for telecommunication, for railway telecommunications. So as my colleague Edouard Chabanier presented, Minerve project has the main goal of Minerve project, we can say it's to bring together all the stakeholders in railway sector in order to boost the entire railway construction ecosystem, which cannot be possible without embracing the benefits of BIM. So BIM technology, it's a real opportunity for us in order to post our working practices and develop the collaboration methodology that is not developed yet. So SNCF Réseau has invested in the adoption of BIM, and we are currently at level 2 of BIM maturity. A quick reminder of different level of BIM. So we start with level 0 based on 2D CAD drawing with zero collaboration. And then we move to level 1 by developing our 2D models to include 3D models, and also start creating a CDA, common data environment, but we are not at full collaboration at this level. Once we move to the level 2, so at level 2, the working practice is full collaborations, and the data source is mainly the common data environment. And then we move on to the full integration in level 3. So currently we are at level 2 of BIM maturity, and as you know, level 2 relies on collaborations. So each railway domain should build their model and then assemble this model and then shared toward a unique digital model in order to perform the clash detections or detection of any design inconsistencies. So these kind of practices that will improve our work methodology cannot be possible without developing the collaboration work practices. So that's why. So at level number 2, the data exchange is very developed. So that's why we need a data format that covers our needs and also our requirements, in order to not lose information while the version will be developed during the life cycle stages of the data life cycle. So the privileged file format for the moment is IFC. And in order to, so I will show you a concrete example of how IFC fell into the BIM ecosystem of SNCF Réseau. So this is a brief schema that describes the BIM ecosystems. And as you know, BIM ecosystem is not only a set of softwares. It's also practices and processes that need to be standardized. So first thing to do, as you can see in this schema, we didn't put all the tools that we need in order to have some contextual element. In our case, we are talking about the terrain, the track alignment, and all this stuff. So we will directly start with the BIM modeling tools. So in BIM modeling tools, unfortunately, we don't have one unique software that can respond to all our requirements. So each domain has its own modeling tool. And we have also a model federations tool. And during the modeling, we need to import or export some BIM objects from our library. So currently we have a BIM object library named BiblioBIM that archives all the 3D models that we have in SNCF. So when we start a BIM project, we will only import all the objects that will be used from this library. And then we go to the project collaborative work tool. So we have so many softwares that provide so many solutions. And the export or the data exchange between the modeling tools and the collaborative work tools is done using IFC. Only IFC for the moment. So in SNCF, we use in IFC. Sometimes we can use some native files, especially when it comes to the alignment, because currently some softwares does not support IFC 4.3. But when it comes to local installations, the official format is IFC. And then we need to exchange the unique federated model with our partners. For example, if we want to work with Sistra, CITEC, Aegis, for example, so each partner should have access to the data, of course, according to his contractual obligations. So the data exchange of the models is done using IFC. And we have also another issue related to the digital continuity management tools. So this is this issue will be addressed by the digital twin. And the concept of digital twin and BIM in IFC, so how we visualize this relationship. So from IFC from SNCF point of view, digital twin, it allows dealing with the daily operations. So it's very proper for operation and maintenance phases. So BIM only covers design and constructions. And this digital twins relies on information systems, which sometimes could be intelligent BIM models. So in order to import data from BIM, in order to enrich the digital twin, we will use IFC. It's not the case for now, but it will be in the near future. And we have also some ACID database and also some internal database that should provide data to the digital twin. For the moment, it's not IFC, but why? Because we need to structure our database in order to be in accordance with IFC. Concretely, I will share with you the first POC, proof of concept, that we have carried out in order to evaluate the efficiency of BIM. So the idea of this proof of concept is to examine how our activities will be leveraged using BIM, and to what extent their effectiveness and efficiency will be improved using BIM technology. So this is a real infrastructure project named High Performance Marseille Ventimiglia project that aims to roll out ERTMS level 2. So ERTMS, it's a new technology used for signaling and telecom in order to improve cross-border transportations. The project's goal is to roll out this ERTMS level 2 in a railway line. So this railway line starts from Marseille and leads to Ventimiglia in Italy. So the proof of concept of BIM technology has shown one, because as you can see, the Marseille Ventimiglia project the scope is too wide. So we have chosen one small pilot line, which is the Cannes-La Boca grass line, which is a 16-kilometer single track railway line. So in this line we have bring together all the railway domains: signaling, telecommunication, electric tractions, and also track, in order to build this unique digital model and export it to the CDA, Common Data Environment, and also test and develop our common use cases. One of these use cases is the collaboration of railway domains during the design phase, and also the testing of the BIM-based design practices. So as you can see, we have marked in bold the collaboration of railway domains. So the main use case that we need to test was the collaboration between all railway domains. So at the moment we have some issues when it comes to the space management, positioning, and also the technical room design. So why? Because this kind of project requires a collaboration of so many actors, but at the moment each domain work at its own. So if we focus on telecommunication, I will not dive deep into the telecommunication requirements, but the idea here is railway telecommunication. We have noted that we don't have BIM objects, and we don't have a model that can be shared with our colleagues from different domains in order to address multi-domain issues and all this stuff. So that's why we have chosen IFC. First thing, so the first use of IFC was to archive and save all the railway objects. So as you know, the modeling of any object consists of combining geometric and also non-geometric data. By the way, the non-geometric data, the properties were defined based on the property set that we have defined in IFC 4.3 project, and IFC Rail projects in general. And the export toward our BIM object library named BiblioBIM has been done in IFC and also other native formats. So this is how we have developed our internal library of BIM objects. So the most of these objects were saved and exported in IFC format. And when it comes to the collaborations in within the single federated model, so here we can see, on the left we have the telecommunication models that have been assembled, and then these models have been integrated in the common data environment that we can see on the right using IFC. So all the models have been exported in IFC, and as you can see from the video, we can check the positioning of all the structures that is located above the track. We are talking here about cable and line infra, and also we have a BTS-based transceiver station that has been positioned next to the track. And as you can see from the cloud point, the position is correct. So this is some example of IFC uses, but when it comes to IFC 4.3, so since the majority of the softwares that we are, or the modeling tools or any other authoring tool that we are currently using does not support IFC 4.3, so we are not fully using the IFC 4.3. As you can see for this example, the export has been done in IFC 4.1. So it's up to the software vendors to be ready in order to support all the requirements that has been added to IFC 4.3. I think this is the end of the presentation.
Well, thank you very much, guys, Edouard and Ashraf, for this interesting presentation of the SNCF project. Thank you very much. The next on the list is Dashuang Li from CRBIM. The stage is yours.
Okay. So good afternoon, everyone. My name is Dashuang Li from China Railway BIM Alliance, also called CRBIM. And so today I will introduce how we applied IFC 4.3 in China Railway. Okay. So first, let's have a look at our journey with the IFC and buildingSMART. In 2015, when we first participated in the buildingSMART, we also published the railway BIM data standard. It's the IFC Rail specification, which have been reviewed by buildingSMART, and then we think we have a negotiation with the other partners, also like some European railway companies, and we decided to jointly set the strategic goals to realize the digitalization of railway. And in 2018, the railway room was established, and the IFC Rail project was launched, aiming to establish an IFC standard which can be applied to railway around the worldwide. So here's some work we've done in IFC Rail Phase 1. We are responsible for track communication, signal, and energy, and we also define work plan and scope, and develop use case and requirements. There's more picture for that. Okay. So in IFC Rail Phase 2, we completed a unit test report and application requirement report, a flowchart, and other documents in such domains. And we verified feasibility throughout the actual China Railway project, which will be shown on the later. And in 2021, we completed the Phase 2, and now we are working on the IFC Rail Phase 3. So we do have some case sharing from China, and we will show what we've done in terms of combining the IFC and IFC 4.3 with the railway project. First, we will start with some buildingSMART awarded project. Like this one is the Beijing-Zhangjiakou high-speed railway. The railway provides the service for 2022 Beijing Winter Olympic Games. So we applied the IFC through the life cycle of design, construction, and operation. And there are so many software we used to deliver the BIM model between the design and the construction, and between the construction and the operation. Here's the technology we adopted, which we call the BIM plus GIS. We use the civil drawing photography data and the GIS map data to merge into a platform which called iDesktop, and then we form the visual display, and it's uniformly loaded and managed on the integration platform. So by using the IFC, the construction period was shortened by 144 days, and the estimated cost saving is $2.36 million. Yeah, it's a lot. Yeah. And another case is Guangzhou-Zhanjiang high-speed railway. It's also which also won the 2022 buildingSMART award in design phase. This it's also used the IFC to make the transfer between design and construction. In this project, the Autodesk Revit and AutoCAD are used to, and they were integrated to the Innovia and the Dashuang to realize the collaboration, which also provided some application for different railway domains, such as the tunnel, the track, subgrade, and bridge. Here's some the BIM model in different domains, and we realized detailed design, such as the rebar design, the steel structure design, and so on to apply the construction. So it showed the potential of IFC, which means we can have a great development in digitalization and collaboration by using IFC 4.3. So we try something in railway projects in China with IFC 4.3, because as we've shown, the previous project are used by IFC 4.1 or IFC 2. IFC2. So we have some test bed for different domains. Here's the first one. We implemented IFC 4.3 in Yanliang Airport Intercity Railway, which achieves simulation, modeling, and integration management via IFC 4.3. especially in the overhead in the power domain. We built the overhead context system via IFC 4.3. The rule and data-driven automatic modeling method are proposed according to the assembly relationship of components, including cable connection and layering. And we loaded many attributes of overhead line, which belongs to IFC 4.3 rail domain. Here's another one, is Wildenauer high-speed railway, which also realizes some application based on IFC 4.3, like collation inspection, visual inspection, beam collaboration, and beam visualization. So this project was focused on the IFC 4.3 signal. And the Bentley is used to test the 3D layout of trackside signal equipment, including the point layout and the linear layout. The third case is Fuzhou-Xiamen high-speed railway. We said this project was focused on the communication domain. We set the base station field model and the trackside equipment models. And based on IFC linear element, the communication equipment are laid on the corresponding the manage of the central line. So we also compared the IFC imported model with the Revit model in the steel tower, and we published the checking report for the software. So the layout effect of various equipment can be visually seen with IFC attribute by measuring the distance between the anemometer and the slipper. It can be detected whether the installation of it is reasonable and whether the limit is violated. So we're also thinking about what's the future of IFC 4.3, and what's the future is the relationship between railway and IFC 4.3. There are so many problems in the development of IFC 4.3 in China. The most important one is the China. There's no China version for IFC. So the research and application of IFC are limited. The operation platform of BIM software cannot be localized with Chinese or with the same language, and it's hard used to Chinese designer to our office work. So that's a little difficult to us. And the development of IFC is dynamic and sustainable, but if we use it in China, it's not it can't dynamic update. So we also need a dynamic updating maximum. So in China, and in fact, we think IFC. For now, IFC 4.3 cannot meet the whole needs of engineering and construction in China yet. So we established a new project called CNIFC, which means the China IFC. It's a set of engineering object digital definition system. And the CNIFC is based on the IFC 4.3. After translating the IFC 4.3, it will extend something to form a set of operable CNIFC common data architecture according to the needs of China engineering construction. Because we all know that the IFC 4.3 for new high-speed railway line only focus on the track, communication signal, and the power domains, like I mentioned before. And in CNIFC, we will develop more domains, and which will be suitable to the China Railway. And the CNIFC standard is combined with the semantics to improve the accuracy and the intelligence level in the implementation process of a standard. So we also develop the CNIFC resource platform and explore the new service model. The CNIFC resource platform will provide professional semantic service and some like online query and expansion of IFC standard. It will also support the establishment of industry data dictionary interface and support reach and development of BIM software to localization for foreign BIM software operation. For now, we are working on the CNIFC standard. We have the general, the architecture, the railway, the construction, and the Asian architecture standards. And we also develop some basic semantics of architecture and civil engineering for the general, for building informatization, and for the carbon emission and sustainable development. So we think that's what's the IFC 4.3 future to China. So thank you very much.
Thank you, Dashuang, for that outlook. And before we come to the question round, I want to invite my friends from UIC, Pierre, Tane, and Airy Magnien, to go further with their presentation. The stage is yours. The click.
Thank you. Yes. So I'm Pierre Tane, Head of Digital Modeling at UIC. I'm here with my colleague Airy Magnien, who will introduce himself when he will start this presentation of some of the slides. UIC, for people that might not be familiar with it, is the International Union of Railways. So it's a not-for-profit organization established about a bit more than 100 years ago, headquartered in Paris. So we have a membership of railway companies, so railway undertakings and infrastructure managers, as well as railway-related research institutes. Our general mission is the promotion of railway transport, and one of our activities, amongst others, is the production of de facto or industry standards that used to be called UIC leaflets, but are now more renamed as IRS, International Railway Standards. And as part of these activities, we collaborate with standardization bodies and industry initiatives, including BSI, in particular on the IFC Rail project since a bit more than 6 years now. We're also involved with for example, with the European Railway Agency, and also with the European Telecommunication Standard Institute around the development of the GSMR and FRMCS standard. For details on our activities around IFC, I'm going to hand over the floor to my colleague Airy, and then I will provide some European context to what we're doing a bit later in the presentation.
So thanks, Pierre. Airy Magnien, I've been working for USC since 2013, and before we tackle the question of the day, that is, what do we do with IFC 4.3? Especially, but not only IFC Rail, I would provide some background because in fact we started some, say, modeling activities before, and that much determine what also we do and we intend to do with IFC in the future, continuing our cooperation. So Indeed, an initiative taken around 2013 was to establish the so-called rail system model. At the time it was called rail topo model, but then the name was a bit generalized. And this model was issued as an International Rail Solution 13100 in 2016. The purpose was to describe railway infrastructure in a not overcomplicated but comprehensive way, and not based on use cases, which is the usual tendency, but being quite generic, that is usage agnostic, trying, hopefully managing to serve as many use cases as possible. And the essential thing is we decided, and that was the first case for UIC, that we will not even sell the paper because the model is free for any usage. So it was rebranded, as I said, rail system model because it's no longer restricted to infrastructure. Nor is it a model replacing all models because, well, this simply does not exist. And we are not going to enter that kind of strategy, I would say. By the way, the last revision I provided here as a reference, a link to the last revision where you will see what we are at. And in fact, the big turn came in 2017 when we started cooperating with IFC, buildingSMART International, noticing that the progress in modeling was slower than we expected. Maybe we're a bit naive. And that was about time to make use of all modeling efforts in a federated way. Model federation is also an expression often used in the context of IFC. Maybe there are slight differences in the understanding, but I think the attitude is the same. So, switching to the next slide, one striking aspect of rail system model, and this also explains some of the relationships with IFC, is in fact, well, in IFC, I heard the day before yesterday, well, everything gets traced back to the alignment. And the alignment itself gets traced back to the topology, and this is what a rail system model would add as a kind of abstraction layer. So in the figure presented here, you see the topology in the middle, and it only talks about, well, this at track level, linear elements being connected to each other, and in some way that is characterized. And then using these linear elements, not caring of geometry, you can add the geometry, that is the alignment on the top, and this we borrowed from IFC. And then you can graft net entities like track panels, switch panels, signals, etc., the whole stuff, that we'll also probably find in IFC in some of the packages. So this is where the models start to interact. And by the way, this apparently obnoxious additional layer of abstraction, that is a kind of relation order we introduce along the linear elements, characterized here by the figures put in the squares. We call them intrinsic coordinates. This is what allows, in fact, to attach whatever you want to the infrastructure in a way that is totally agnostic, and, by the way, also solves a couple of additional problems, like, for instance, well, when you are at design stage, you try to draw on the canvas. When you have a built infrastructure, you usually, as a railway company, would use linear positioning, more or less according to ISO 19148. And of course, when it comes to laying the whole infrastructure on the map, you would use all sorts of geographic or geometric positioning system, latitude, longitude, easting, northing, and these were the intrinsic coordinates, which again is a distinctive feature of a rail system model, would allow to establish a correspondence in a secure and non-ambiguous way inside the model itself and not inside some additional tooling. So having that basis, it was of course tempting to attach IFC classes, industry foundation classes, to the model. And here, by the way, I showed what we attempted to do already in 2019, I guess. In blue, you have the rail system model classes, base object, linear location, spot location, somehow related to the topology. I spare you the details. And in the middle, you will recognize in green the IFC alignment classes, including what has been added for the purpose of railways, that is lateral alignment, cant alignment. as additional notions. And in fact, we managed here to realize what is called low coupling but high cohesion in modeling art. That is making sure that the two models talk to each other, reference each other to some extent, or may reference each other, and are not redundant. This, for that practical purpose, we made a kind of shortcut. That is, we cloned the classes in UML, but maybe there could be other ways to couple the model than just cloning into some modeling tool. Now, practically, looking forward, I think there are a couple of issues we might try and close together. One is called Mind the Gap, and by the way, the picture you see on the right, I shot this morning in the Metropolitana that brought me to the Congress Center here. It is one of the big issues we have when we set up stations, especially when we prove the conformity to the technical specification for interoperability that deals with people with reduced mobility. So in terms of conformity assessment, this is where usually the trouble starts, and it gets even bigger when you have a station in a curve, because then it is very difficult for the train to follow the alignment of the edge of the platform. Now it looks like, sorry, wrong button. It looks like, indeed, we can find in IFC more or less the elements we would like to use. That is, we need to describe the platform and its properties, especially geometric ones. Problem is, well, railway platforms are not really there in the IFC catalog. I did find IFC road parts called Refuge Island, which exists, but I would like to create or reference a rail platform class. Currently does not exist. Also, especially because there is one property, which is, by the way, not a numeric property, but a geometric one called platform edge, that I need to characterize and put in a relation with the position of the train itself and of its stairs. So this is why in my model, I would like to reference that kind of classes that could be derived from IFC. And the question arises, and this is for future work I hope we can do in common, that is, how to make sure that when we need to specialize an IFC class, we can instantiate it, reference it, publish it as a part of a catalog extension. Maybe not finally as a part of some version of IFC, because not every extension that is needed for a particular project, it needs to be generalized. Then, in terms of conformity, there are also very important issues that, by the way, are being hotly discussed right now on the buildingSMART IFC GitHub. Verification, validation, monitoring when things are getting operated means matching uncertain measurements with tolerance specifications. And here, lo and behold, IFC has it all, at least on paper, because you get p-set tolerance, you get p-set uncertainty. And then, of course, you get on the GitHub discussions saying, well, it's likely that maybe the complex properties would be made obsolete, etc. And others say, no, not so, not so. And there is, I sensed a certain people being uncomfortable about using those IFC components that probably would need more advertisement and maybe guidance in the way to use them. And more importantly, I think that those notions of tolerance and uncertainty are absolutely fundamental to engineering, especially mechanical one, and they should be used absolutely beyond the usual IFC scope. So how is, of course, the question. Again, I don't want to be overly redundant. Then there is yet another aspect that will be the last in my list, I guess. Predictive maintenance is being envisaged as one of the solutions to contain the huge expenses of maintaining railway infrastructure, which is one of our handicaps. So fact is that objects, whatever infrastructure object you are looking at, does not know its condition or its state of repair. the state of repair is observed by others. On the other hand, it has to comply with specifications. This is why inside a rail system model, in one of the very, very basic packages, we decided to implement the so-called SOSI and SSN vocabularies published by RWR3 that exactly allow to keep in one place, I would say in one model, the three aspects, at least three aspects of data that you may manipulate, or data values that you manipulate. And these were mentioned earlier this morning in a conference with the airport group by a person responsible for BIM at the Milano airports. He mentioned I want to manage the prescriptive, predictive, and descriptive aspects of data. What should be, what is, and what we predict it will be. Slight difference for the time being. I just had a chat with him. He's doing that by hard coding the prescriptions in the code itself, in the tool set. And my mindset is, well, so let's envisage to have the three aspects in the model rather than in the code, which is probably more flexible and also very useful to keep the coherence on between the observed values, the prescribed values, and the predicted values. Everything toleranced, of course. So this is where the handling of the model might become complex, so I would also warn myself against doing such things without sufficient thinking. But fortunately, there is a publication I mentioned at the bottom that might be aware of by Peter Powers and others who spend some time reflecting on the way to represent properties and property values, maybe in some indirected way, but maybe serving that kind of purpose. So that's typically also a field I would like to further investigate, certainly not alone, but with you guys, if you're interested. Now, IFC Rail is also gaining momentum in the context of Europe's rail modeling activities. So Pierre will lose a few words later on about Shift to Rail and Europe's rail joint undertakings and what all belongs to it. On a more microscopic aspect, I am already working on the third project where IFC plays a role, including IFC 4.3, or at least the premises of it. The first one was the Optima project. It was about setting a traffic management system at an intermediate technical readiness level. And here, the challenge was to extend the models according to project requirements in a semi-automated way. The next project, in fact, running in parallel was Links for Rail, about setting up a conceptual data model and a data dictionary. And of course, it rings like BSDD. And again, I figured out, well, no use doing redundant things. IFC Rail is there to stay, and apparently it's confirmed today. And we integrated, in fact, IFC Rail classes in the so-called conceptual data model that also joins the rail system model as a skeleton and glue, so to say, and then other models like transmodel, U-links, etc. So here the challenge was absolutely the federating. So far, I think the challenge has been successfully addressed, including data serialization, by the way. And the current project is Motional FP1, framework flagship project 1, which is about, it's a follow-up of the Links for Rail project, where the challenge is even bigger one. It's about federating not models of the same style, more or less conceptual model, but heterogeneous models of different types. Some of them are system architecture, some are real-time data exchange models describing interfaces, and so models are very different in nature. But here, as I put it in the top mention, the key is shared semantics, which is, I think, our common effort, both IFC Rail, rail system model, and others. We are really trying to share semantics, not just data structures that may vary, but the semantics that should be as stable as possible. And this is where I hand over to.
Thank you, Airy. So just a couple of words on these European initiatives. As I think Airy demonstrated, we're looking not at reinventing models where they exist and why is it moving. Okay, it's not moving anymore. We are looking at federating, so linking between models. So RSM doesn't want to replace all models, but link to existing models. And definitely we see value, as exemplified through many aspects. We definitely see value in the concept that have been developed within IFC Rail. So just to make you aware of what we're doing from that perspective, so the outcome of the Links4Rail project on the conceptual data model has been now ported to the new family of projects called Europe's Rail Joint Undertaking, for which there is 6 flagship projects, 1 to 6, plus System Pillar, which is more of a governance authority, I would say, working especially on architecture. And so what we're doing within this flagship project is to gather data requirements or data offerings from these various work packages in all these projects to figure out how to extend the conceptual data model to introduce new concepts. Eventually, when people have needs, if we identify what they need would be already in IFC Rail, then we point them to this kind of concepts. If there is extensions required, we work out where to do that extension, and then liaise potentially with some of the federated models to actually develop them. And ultimately, FA1 or FP1 actually just started end of December. It's going to run over something like 4 years. Ultimately, the idea would be to have a conceptual data model covering as much as possible of the entire railway system. And then there are also activities within FP1 around data exchange formats, for which we're exploring multiple variations of that, either platform and project independent representation using ontologies, or when it's required in particular for real-time communication, platform-specific data exchange format that would be devised. And there's already one which is under development within the system pillar for the CCS domain. So the approach is really to try and benefit from the collective work that is being done in various initiatives, link all of them together, and then make them available to the overall rail sector.
And now to come to a conclusion. Here I will quote what I heard yesterday in the ISO, CN, etc. standards panel, because many things said by the panelists rung to my ear. I've noted them. So here, sorry, I could not credit everybody, but there was certainly Jim Plume and Oyvind and others from the panel. So some said, well, having defined 5,000 classes does not imply that we know everything. Absolutely right. And I would add that we could even settle maybe with less classes, because the interesting thing in modeling is you can make derived classes when you need them, publish the derivation so everybody understands what you do, but you don't necessarily put them back into the standard itself, because after all, it might not be necessary. The second sentence was, we are all in the same boat or in a fleet of boats. Yes, indeed, as you saw, I like the idea of federating models that contribute to each other and fecundate each other. But for having such a fleet of boats, we need competent and friendly captains. It is certainly the case. I must say I've been working for 6 years now with the IFC colleagues, and that was a highlight in my career. But careful here. We could also come into political waters. The third sentence was, the standards are there, start using them. I hope you were convinced that we started using IFC. Now in different manner, because you understood that at UIC we are not in the business of implementing, of generating objects in the field. We are only in the business of designing models. So here cross-referencing models for us is the turf. Fourth saying is, we should not be afraid of linked open data and should recognize their value. Please have a look at ontorail.org. I will not say more because it's not the main subject for today. And the standards are an empty shell. If we don't have the tools to support them, well, this is also why we developed ontorail.org, and we should be maybe doing even better than that. So that's all I have to say for the time being, using every other people's words, so sorry for that.
And just maybe one last word on that. So definitely, I think it's quite clear from and just maybe one last word on that. So definitely, I think it's quite clear from. Thanks for inviting us over, Winfried. It's very clear that IFC 4.3 is moving forward, and we see that there will be efforts towards producing data in that using IFC 4.3. From our perspective, it would be wasteful for people in the sector to essentially redevelop something different when we could actually link those models together. So there are areas where, and there was a question I think yesterday about some of the projects and how they related to IFC. Sometimes the granularity of information is much higher than what IFC would provide, but that still doesn't mean that we would not need some of the things that would be in an IFC data. And in some cases, I think we could even directly use the representation of the data that's present in an IFC file, and then reduce the effort that we would have to do to actually complete railway projects. So we're very hopeful for the future about this.
So very, very happy to have you here, and thank you very much for your outlook here and for your presentation. And especially for the conclusion, I think, because that's always in my mind, to have not fighting standards each other, but linking to them and using the advantage of the one and the other standards. So I always say, together we are strong, and that's what I think is also the mindset of URC in their developments. The second point I want to say is, as you see, IFC 4.3 has influence. Still, it's even not an ISO standard yet, yeah, but it has influence, and it's about being used in the world of rail. Okay, so I will stop now, and the stage is yours for a couple of minutes, hopefully. Are there some questions to the guys here on the stage? Somebody needs an icebreaker. Christian. Stefan.
Stefan Reiser, Swiss Federal Railways. Thank you all for your presentation. I would like to pick up the picture of a fleet of boats. From my impression, with not being involved in the whole IFC process, it seems like the fleet of boats now is coming to parts, and everybody has a rest and tries to implement the standard in their organization, which is absolutely fine, and I think a natural process. My question would then be, how does the Railway Room, or how does the future development of buildingSMART International make sure that all the learnings that that might come up when implementing the IFC in their organization, or adapting them to their national needs, how does that merge together for the future development of IFC?
I've hoped I can give the question to some of my colleagues, but I think it's to me. So, yeah. First of all, the Railway Room is not an institution. The Railway Room is all of you. So it's the job of all of you to have these things, to bring these things further, and it's a kind of platform where you can exchange information and so on. This is my first answer. The second answer is, of course, in the development of the standards, and of course some, let's say, some services which support the standard is on buildingSMART development on the way. Let's say, this would also be a question from my side, the buildingSMART data dictionary, which is a service, which is not a standard, but which is a service that supports to have these things which are not in the maybe not in the IFC standard implemented, but are necessary to be discussed or to be defined. You can link that. So buildingSMART Data Dictionary is one of the things. If you use that, and maybe I will ask some of you how do you think about that. This is the one point. The other point is, for instance, this kind of validation services which are there, so that you can check if your standardized data exchange files, models, whatever, are correct in the kind of manner. So this is one way of buildingSMART to bring things further. And I think the third point is, and that's what I'm trying to live here, is to bring people together and to discuss exactly that topics. And so the railway room is we are still developing. It's now was Rome, and after Rome we will go further again with the roadmap of the railway room. And I think there, from reading the roadmap, we will have a good picture of the future for the rail domain in buildingSMART.
Thank you.
So another question from the auditorium. Circa Maximo. Francesco.
It's not really a question, but that came after you mentioned the dictionary. But dictionary is already made or not?
There is a system for the dictionary which you can use, and at the moment we have had a discussion with the airport room, railway room, airport room, and some colleagues from infrastructure room, how to go further with that dictionary. So how can we? As we said before, in the IFC standard, you cannot define everything, because then it's unmaintainable and very complex. So one of the guys in the discussion said, let's have few classes and then describe them into a more an open platform where everybody has access and could go further. So it's also, and that's maybe what also my question is to you colleagues is, do you think in your company is the buildingSMART Data Dictionary, is that a way you want to go with? Is that useful to have this kind of data dictionary where you can link to the standards, and where you can link also to other dictionaries and other stuff to discuss things? Adrian, maybe?
Sorry, just to, because there's in the CEN and CENELEC and the ISO and the IC, that's, we are talking about the rail, no? Okay. There are already the definitions for the most part of the things, so we not need to invent the wheels. So
absolutely,
yeah.
What's needed, and that's why I'm asking for the buildingSMART Data Dictionary, for a data dictionary, in that case buildingSMART Data Dictionary, is that you have a platform where you can put it on the platform, your definitions, yeah, and then you can link it to the standard, so you can make a big picture of your own knowledge, and you can discuss this with others. Adrian, so maybe.
So it's a good question. So I was just tend to answer it with yes, but it's a bit more complicated, or complex, not complicated. So as he already said, I think it's most important to have the national standard, not standards, the national data dictionary, or let's call it the amendments of IFC Rail, uploaded to the BSDD and using it then. So I think that would be most beneficial to everybody. So I have uploaded, for example, the SPB data catalog to BSDD and then using it from an external qualified and tested source. Could be.
That was also the point in the discussion with the airport room, railway room, and infrastructure room. What is the best way to get there? And so, is it first harmonization and then publishing? Yeah, or is it the other way around? But that's always the same question. I think we should come very quick to a solution how to go further. That's because I think it's necessary now to have things on the table which you can use, and maybe it's not complete, but it's usable.
If I just briefly may add something to the topic of the BSDD, because I was involved in the product room for several years now, and I witnessed the discussions about the BSDD that we had in the product room yesterday and today. I think BSDD as a service is a phenomenal offer from buildingSMART International to provide data to users. And I think from all the presentations we've seen on the board here as well, everyone has a need for a data dictionary in some sort of form. The BSDD was advertised as the dictionary of dictionaries, I guess, in 2019, and that has now changed, and there is no new product owner, which is a brilliant guy, by the way, to then guide the BSDD up to a new level. I think with the advantage of having IFC 4.3, or especially everything that has to do with rail on a data dictionary, maybe the BSDD or maybe any other data dictionaries, that it has been data and information which is being created by experts, so it's trustworthy for people to use it. And that is the main issue that the BSDD has, but that is not an issue that railway or the rail domain has, because we could say that everything that has to do with IFC and rail has been created and well validated by experts. But to answer your question, the BSDD is there and usable.
Absolutely. Okay, some questions.
Quick question, which might be more an opening. I noticed from the CRBeam presentation and also the UIC linked data. Whereas I noticed IFC 4.3, IFC old maybe needed some tender and care, wasn't less of a priority for the last years. So what's your view? Should we put the emphasis on the linked data, expressing the IFC as a linked data standard? What are your ideas or needs in that area?
Sorry, I'm not very clear about your question. Can you just repeat it in detail?
Okay. Last slide, I think, or toward the end of the presentation, you were opening the subject. What's new for IFC deployment in the future? And you mentioned linked data, augmenting the semantics of IFC by linking to other standards using linked data. Whereas IFC so far is still an express schema. It's not. It has been in the past converted into IFC old, but not the latest versions. So does it mean that you're back into the subject and ready to invest some time to render IFC to provide the IFC as a linked data standard as well?
Sure. Yeah. That's the one part of our plan, but. For now, we just plan to do something about the knowledge diagram and some and a platform for combining the IFC standard and some semantic and some, like you mentioned, the link between the data and the standard. We are working on it, but for now we just start at the beginning of the work, because like I mentioned before, we found that there's so many problems to develop the IFC standard in China, and this one is just the most important one, and so we will first solve this, but now it's just the beginning. So And maybe in the next summit, we will present some more details about the platform which link the data and the standard. Maybe next summit, I think it's cause let me explain in detail. Cause the IFC project I mentioned is from the buildingSMART China chapter. So, but this time, cause we are involved in this project, and we are in charge of the IFC standard of railway domain. So maybe we can get more information via the buildingSMART China chapter and at the next summit. Okay.
Thank you. Maybe you.
Yeah, just a word on this. So we, on the OntoRail project was mentioned by Airy. The idea that we had was to extract ontologies from models when they were not in an ontology direct form. And the idea was indeed to essentially create linked data, even if it's not already in a linked data form. The more we discuss within the RWR3 joint undertaking, I was mentioning, the more we identified that there could be other models or even ontologies already ready that we could use to further linking. So I think that's definitely a trend that would be, I think, going the right direction in order to prevent reinventions, because what we see also at the same time, it's a bit contradictory to what I said, but sometimes we see people that say, oh, well, let's make it more simple. We're going to redo essentially what you did, but in a different manner, and then we are back into square one about multiplying standards. So I think there's I think a form of kinship in spirit between what buildingSMART has done with BSDD and what we have been trying to do with the OntoRail project. Not exactly the same approach, but kinship in spirit. So.
Thank you. Another question? So it's always hard to be the last, the last between you and the beer. Okay, guys. So thank you very much. Thank you very much for my colleagues here on stage. Give them a hand and yeah, enjoy Rome.